So yeah, I would say financial support made PV and batteries competitive. And I would also say that is what we need for green energy partnerships. And that is also the topic for today. So hello everybody, my name is Alexander Meisinger. I'm a PhD candidate at OTH Regensburg in Germany. And today I have the pleasure to give a talk about financing energy partnerships beyond Europe through H2Global, where we have done a case study on the way to a European African energy transition. And for this, I want to invite you to our chicken coop and the famous chicken egg problem. To be honest with you, I still don't know the answer about the real chicken egg problem, but what I know is that we can directly link our chicken egg problem to our hydrogen problematic with the main question, what came first, supply or demand for green hydrogen? And for this, our chicken coop is actually our green energy exchange. And we have on the one side Europe in our case, which has high climate targets, but also high energy demand. However, if we don't have enough hydrogen supply, we will not see any energy transition. And the customers in Europe, they are facing the problem that the hydrogen price is too high at the moment. On the other side, we have Africa, which also has climate targets and high renewable potentials. However, if we don't see any hydrogen demand, we will also not see any hydrogen expansion. And the producer are facing the problem that the hydrogen price is too low for sale. And this represents actually our chicken egg problem. And there are already some ideas to solve this issue. And one of the ideas is the H2Global instrument, where we have set the focus on. Some information about the H2Global instrument, or let's say in our case, the incubator of our chicken egg problem. So the H2Global instrument represents both sides. So on the one side, we have the producer of hydrogen and its derivatives, like different consortiums or companies, in our case in Africa. And on the other side, we have a customer of hydrogen and its derivatives. So for example, different industries, the transport sector or the energy sector, in our case in Europe. And as I already mentioned, is that there is like a price difference between both sides. So therefore, we need a funding body. And this is actually where the H2Global instruments is based. It is also called the double auction mechanism. So we are doing some auctions on the producer side, and we are also doing some auctions on the customer side. And the difference between both of it needs to be compensated by the funding body in order to ramp up the hydrogen market. And this leads us already to the main research question. So what role does the H2Global mechanism has in financing green energy partnerships to ramp up the hydrogen market? And to answer this research question, we want to come up with one main feature, which can be seen here, which has two main aspects. So on the one side, we want to illustrate different African countries and its hydrogen export cost in relation to the hydrogen export volumes, which can be seen here with the blue column. On the other side, we want to show the willingness to pay for hydrogen in Europe, which should be illustrated here by the green line. And if we match both of it, we want to identify the budget gap, and we also want to identify the role of the H2Global instrument. For this, we are using energy system modeling and actually two different energy system models. So one of them is the Pipes Europe energy model, which is, as you may know, completely open source. And we have integrated the Green Deal scenario and a business as usual scenario within the energy framework. And we played around with different hydrogen import costs in order to come up with such a line. And in our case, the Pipes Europe model represents the egg of our chicken egg problem. The other model is the Pipes of Earth model, which we use for representing different African countries, which can be seen here. As you may know, it's also open source as well. And we have integrated different country codes and we played around with a variation of hydrogen export volumes using shipping and using different transport mediums like liquid hydrogen, ammonia, and methanol. And we also consider a reconversion to hydrogen in Europe. So to be a little bit more detailed, I have also added this slide. So within both energy models, we did some extensions. So for Pipes of Europe, we add multiple costs for hydrogen imports as a wildcard to be more efficient. Within Pipes of Earth model, we have added export by shipping using the transport medium liquid hydrogen, ammonia, and methanol. And we also considered hydrogen conversion at the import side. For this, the code from Eddie Chalbot was quite helpful, which was also open source, and we extended it in this case. In addition to that, we built up our scenario. We considered two different years, 2030 and 2050. The costs are in accordance to technology data and year dependent. For the hydrogen export delivery, we assume a range of 5 up to 15 terawatt hours in the year 2030. And for 2050, we assume a range of 25 up to 75 terawatt hours for each African countries. And for European countries, we assume a hydrogen import cost between 0 and up to 200 euros per megawatt hours as 10 steps in order to come up with such a demand curve. So now that you have a better overview about the methodology, I want to finally jump to the results and starting with the year 2030 and considering hydrogen export from African countries using liquid hydrogen as a transport medium with ships and transport it actually to Europe and considering a reconversion of hydrogen. So in this figure, there are like what we can see is that we have different African countries on the one side, and its hydrogen export cost in relation to the hydrogen export volume. So, for example, if we want to import 5 terawatt hours, then we see that actually Morocco is a good option. If we want to increase the hydrogen volume, then we see that also Egypt and Mauritania is a good option if we consider 20 terawatt hours. This is the one aspect of this figure. The other aspect is that we see two different lines representing the willingness to pay for hydrogen in Europe. And one line is representing the European Green Deal scenario, and the other line representing the business as usual scenario. And what we can also see is that the value of hydrogen change if we consider a Green Deal scenario. So if we really follow climate targets, then the value of hydrogen is much higher compared to a business as usual scenario. However, what we also can see is that there's a budget gap between energy supply and energy demand. So therefore, we need financial support, for example, with the H2Global instrument. If we jump now from 2030 to 2050, then we see that a lot of changes are going on. So now, if we consider the Green Deal scenario, so the green line, then we also see like a wide gap, which means that now the market is competitive. So we don't need any financial support
Ciao,
anymore up to 150 terawatt hours. So now the next question would be, okay, how much budget do we actually need
ora sì, mi
uh, to
senti?
fin to finance everything? And that is what we can see here on this slide. Considering a Green Deal scenario and using hydrogen export by
Mi
ship with the
senti?
transport medium liquid hydrogen. Sorry, Davide, I think
Sì,
your
io ti
microphone
sento.
your microphone is not muted. But I just continue. What we can see in 2030 is that we definitely need financial support, depending on the hydrogen export volume. However, in 2050, actually, the budget is negative for liquid hydrogen, which means that the market is competitive. If we now consider not only liquid hydrogen, but also other transport mediums, so for example, ammonia, then we see it's not competitive compared to liquid hydrogen. So we need financial support in 2030, and we also need financial support in 2050. And this is also the same case for methanol. If we consider reconversion in Europe, that's an important point. So the main summary is that liquid hydrogen is actually the cheapest option by ship to transport it to Europe and consider reconversion to hydrogen. So these are the main results. I just want to sum it up and give some key takeaways, or in our case, an egg to go. So we have seen a chicken egg problem. So no hydrogen supply, no transition, no hydrogen demand, no expansion. We have seen a cost gap, so financial support is definitely necessary. We use open source energy models in order to analyze that, in order to analyze the role of the H2Global mechanism in Europe and in Africa. And key takeaways are that the H2Global mechanism is essential in 2030 and no longer relevant by 2050 if we consider liquid hydrogen as a shipping medium. In Europe, we have seen that less progress on climate targets results in higher budget needs. And in Africa, we have seen that shipping hydrogen via liquid hydrogen is the least cost option compared to ammonia and methanol. So, what came first, the chicken or the egg? Honestly, I still don't know the answer, but I would say the most important thing is the incubator, so the financial support of hydrogen. Thank you for your attention. Uh, if you liked it, feel free to follow me on LinkedIn, and here you can also find my repository. It's completely open source. Thank you.
Thank you, Alexander. Thank you for your presentation. Thank you for also sharing the link to your repository. Maybe if you also want to share a link in the chat so that anyone who's interested from the audience can go to it and check your repository. That would be great in case they didn't have time to use the QR code.
Perfect.
Now, yeah, thank you. Now we have questions for you. You can keep asking questions. There's Slido link, as we did before. If we don't have time to go through all of them, we will just put them in the chat, and the speakers will be
Sure.
answering to them if they wish. So the first question we have here is, we missed the assumption info about why H2 in Africa is and will be cheaper than in Europe.
Well, it's not always the case that hydrogen in Africa is cheaper than in Europe. So if you consider the supply and demand curve, what I have shown, it's only the case for shipping it with liquid hydrogen. And so therefore, I can only answer this question that it's not always the case. However, what we definitely see in Africa is that they have pretty high renewable potentials, which of course also affects the cost of hydrogen. However, if we consider the whole system and also consider the transportation of hydrogen to Europe, we see, of course, additional costs. So therefore, only some volume of hydrogen will be cheaper compared to Europe, but not in general. I hope I could answer the question. Daniele, you're still muted.
Oh yeah,
Yeah.
yeah, sure. Thank you, thank you, Alexander. Yeah, I was saying if the person who asked this question has anything to comment,
Mhm.
just do it in the chat or Slido. So I don't think we have any other questions. Maybe just give me a few seconds more in case someone wants to raise any point.